In PSC1 Lesson 5, you'll be able to solve problems using the relationship between the ratios of the parts into which parallel lines cut the sides of the triangle. You'll actually be learning another way to solve some of the problems you've already been solving and may consider today's work a bit of a shortcut for you. When we have parallel lines in triangles, what happens is if the lines are parallel, then the sides are split proportionally. In our triangle, these two lines we're saying are parallel. So in other words, A over B has to equal C over D. Notice with this, A and C are on the same side, B and D are on the same side, so those are lined up in that manner. You cannot say A over D is equal to B over C. That would not be a correct relationship. But if you wanted to set it up, you could say A over C is equal to B over D. That would also work. Just make sure you're being very careful in how you set those up. The converse, or working the opposite direction, is also true. If two sides are split proportionally, then the lines are parallel. So if A over B is equal to C over D, then the lines we could call would be parallel. So if you're given a problem where it asks if the two lines are parallel, all you need to do is set up two ratios and prove that they are proportional, either by simplifying to show that they are or by using cross products. So what this is saying again here, we can have A over C is equal to B over D. This also works when I have more parallel lines. So in this bottom one, I can say A over D is equal to B over E, which is equal to C over F. When we are using this, we can only use two ratios at a time. So maybe I'm using these to solve for an unknown, and then I could switch and use these to solve for an unknown. I could also set up a proportion using these two, which would be A over D equals C over F. Even when you're seeing these three ratios, you can only use two at a time. Let's take a look at an example. So it tells us that EO is parallel to LN. So these two are parallel. We need to find Y. So here I can set this up as 48 over 60 is equal to 36 over Y. Now we can cross multiply to solve. So 60 times 36 is 2,160 equals 48 times Y. Divide both sides by 48 and we get 45 equals Y. Here's another example that's very similar. We have two parallel lines that is telling us that. So I can set this up as 8 over 9 is equal to 10 over X. Cross multiply, 8 times X equals 9 times 10, which is 90. Divide both sides by 8. I get X equals 11.25. This example is slightly different. It's now asking if the lines are parallel. So we're going to use the converse. We're going to set up our two ratios. So we're going to use this for the first one, 12/15. And we want to know if that's equal to the other ratio, which is 16/25. We could cross multiply, we could simplify. Either one is fine. 12/15 simplifies to 4/5. 6/25 does not simplify. It stays as 6/25. I know some students might look and be like, oh, but I could take the square root. Well, you can, but that's not a legal math move for simplifying. You can't just take the square root to simplify. Okay, so these are not equal, which means that these are not parallel. We cannot conclude that they're parallel because of this. In our last example, it says to solve for x, solve for y, and z. When I look at this, I can see that I have some parallel lines, so that's going to help me. I also see that I have this relationship, so I'm going to use that one to help me find x. So I'm going to say 4 over 5 is equal to x over 4. And I'm going to solve for x using cross multiplication. So 4 times 4 is 16, which equals 5 times x. Divide both sides by 5, and I get x equals 3.2. Now I'm going to use that green one again, so 4 and 5, to help me solve for y and 6. So I will set 4 over 5 again is equal to, this time, y over 6. I'm going to cross multiply. 4 times 5, which is 24, equals 5 times y. I'll divide both sides by 5, and I get y equals 4.8. So we have our y, we have our x. Now we need to find z, but we cannot use the same method because 4 and 5 are in the same triangle, but 6 and z, they're not on those corresponding sides. They are not being split by parallel lines. So we're going to have to look here for some sides that correspond, which I can show you if I can look at this triangle, and then I can look at the big triangle, and I can use sides that correspond. So I can say 5 here can correspond with this whole length. And I can see that 6 here can correspond with z. So I can use that information. Let's do 5 over 6 is equal to 5 plus 4 is 9, plus 6 is 15 over z. Now all I have to do is cross multiply to solve. 5 times z, and then I have 15 times 6, which is 90. Divide both sides by 5, and I get z equals 18.